Okay, so taking a look at the next page, we're going to talk about finding complex solutions of quadratics. I'm actually not going to do the one for the quadratic formula in this video. I'm going to leave that up to you guys. I think you've had a lot of practice with quadratic formula at this point. Be on the lookout here to see if there's an imaginary number involved. For part A, completing the square, all right, let's take a look at the directions. So find the exact roots. No decimal approximations for the following quadratics. So we have a few different methods we could use to solve these. For this one, we're going to complete the square. So we know our steps for completing the square. We're going to start off by subtracting 5 from both sides. So we're moving that constant over. And then I'm looking at that leading coefficient. It's not 1. I'm going to factor 3 out of both of the terms on the right. Now this is the point where we're looking here and we're thinking, what can we add into that side of the equation to make this a perfect square trinomial? Well, if I take -4, divide by 2, and square it, that's +4. So I'm going to add 4 inside the parentheses. I need to remember that I have to add something on the left side as well, so I'll leave a space. Adding 4 inside the parentheses, you've now forced that perfect square trinomial. However, we haven't technically added 4 to the right side. We've added 4 times 12 because of that distribution. Therefore, here, to keep a balanced equation, I'm adding 12. Now I've got y plus 7 equals 3. Factoring this, that becomes x minus 2 times x minus 2. And then I've got y plus 7 equals 3 times x minus 2 squared. Now, this is the point where the directions are important. So the directions did not say find vertex form. The directions did not say just complete the square. The directions said find the exact roots for the following quadratic, right? So to do that, roots, remember, that's another way to say solutions, to say zeros. So if you're looking for the roots of this equation, you want to figure out what does x equal when y is 0. You're finding your solutions for x, essentially. So we're going to let y equal 0 at this point, and we're going to solve for x. So now you should only have one variable in your equation. And solving for x here, you're just following your steps to solve any equation. So 0 plus 7 is 7. Starting to shrink the equation down. On this side, if you're solving for x, you're basically trying to isolate it, right? So we want to start taking things from this side and sending them to the left. I'm going to move up here, so I've got a little bit more space. I'm going to rewrite that equation. 7 equals 3 times x minus 2 squared. If you're trying to solve for x and isolate, well, why don't we move to dividing by 3 at this point? So 7 divided by 3, I'm going to keep that improper fraction because the direction said find the exact roots. So no decimal approximations here, keeping everything nice and exact. All right, now is the point where I want to get rid of that square, so I'm going to take the square root of both sides, remembering that plus or minus in front of the root. And this is the point where you're almost done. We can drop the parentheses. We don't really need them anymore. And we can add 2 to both sides. So I've got 2 plus or minus, big square root, 7/3 equals x. But technically you're not done. And the reason for that is because we have a fraction underneath the root. And so we can't leave it that way because that's like leaving a square root in a denominator. And here's why. So this is actually the same thing as 2 plus or minus the square root of 7 over the square root of 3. And that square root of 3 in the denominator, can't leave it there. So what we're going to do is multiply this by root 3 over root 3. And we're getting pretty close to our final solution. We have 2 plus or minus the square root of 21 all over root 3 times itself, 3. These are our solutions for x. They are exact, not approximate, and there are 2 of them because there's that plus or minus. So that's how you can solve by completing the square. I'm going to leave it up to you to do it via the quadratic formula. Hopefully what you notice here, there's nothing imaginary. That's okay. This is still a complex number, right? So all numbers are complex numbers. Numbers that are only real, or numbers that have a real and imaginary part, right? So this is still a complex solution to the equation.